So question number 6 1. Okay, same kind of question. Find intervals in which following function are strictly increasing. This time they have said strictly increasing or decreasing. Okay, in this case they didn't say that one. Basically your all function which we have find out, if your f dash x is you are taking greater than 0, then it will be always strictly increasing. If you take greater than equal to 0, means you include those points where the derivative is 0, right? That is neutral point. If you include that, then it will be simply increasing. Okay, if you don't include, then it will be strictly increasing. Okay, till now I hope you have understood the difference here. If you have understood what is the purpose of finding derivative here. Okay, I have already explained many times. You please watch all those videos carefully. You can try to understand with the help of graph only, because most of the student I have seen that they simply try to practice this problem and they used to derive and then used to follow the rules. That's it. They don't try to understand the graph. That's the reason they used to find it confusion little bit when to find out the interval where the function is increasing or decreasing. Okay, to find interval properly, to understand that, first thing you need to know with the help of graph. Okay, so in this case also we have to find out the interval at which the function will be increasing or decreasing. Okay, strictly increasing. So basically this is a function which have a picture, right, in a graph. So I don't know what kind of picture it will be, whether it will be like this, increasing or decreasing, we don't know. So with the help of derivative we will find out. So how derivative help us? So first thing, let me differentiate this one. So f dash x. Now in your question they have not given fx. Okay, it is given only x square. You can see here x square plus 2x minus 5. So that's why in your answer I have written here, let fx equal to this. Okay, so you can mention like this. After that, f dash x is equal to twice of x plus 2. Okay, so in this case also, now see, in previous question I didn't find out critical point and directly I've done. In this case also you can do directly. Okay, but still I will show you with the help of the way I have solved the previous question, that is question number 5. We used to find out critical point and from there we used to find out where the graph will increase and where the graph will decrease. So basically what we will do is, if your graph is suppose like this, okay, suppose, so here you know your f derivative will be 0, here it will be 0, neutral. So you can see after neutral point, you can see the graph is changing. Here it was increasing, it become neutral and then decreasing, neutral and then increasing. So after neutral, always the graph will might change. Okay, it might be increasing, no problem. It might be like this also. After 0, it might go like this also. Again, it might increase. But you see here at neutral point, it changes direction, right? Increasing, decreasing, and then what happened? It become neutral here. Okay, and then again start decreasing like this. This also might be the graph, but we know that if you know neutral point, you can know on your left of the neutral point whether it is graph is increasing or decreasing by putting the value in the function, right? And not function, in the derivative, I mean. Okay, in your right also, if it is decreasing or increasing, how to find out? By putting the value x we will take, and then we will find out f derivative, that is slope of tangent, we will find out here. If it is negative value, okay, then we will understand that the graph is decreasing on your right. Okay, on your left I will take any, at neutral point you will find out, right, x value what it is. Once you know neutral point is this one, at x equal to this will be f dash will be 0. Then after that on your left, that is you take any point on left side x, you will see that for all values here, for all x, you will see that the slope of tangent will be always positive, means it will be increasing. Okay, you can see if I draw tangent here at this point, with x-axis what angle it is making? Positive, right? On your first quadrant. So if it is on the first quadrant, the angle we know it's positive always, right? So you will see that the slope of tangent, that is derivative, will be positive there. So that's how we will use the concept in this case. Okay, so what I will do, I will find out first critical point where the graph will change. We will find out. So for critical point, you can write neutral point also, no problem. F dash x, your derivative is used to be 0, right? Your slope of tangent used to be 0 wherever your critical point is. So from this we will find out where the critical point will be. 2x means x value I will find out is equal to 0, which implies 2x equal to 2. You will bring this side, minus 2 it will be, right? So this will imply x equal to minus 1. So you will see that at minus 1, when x is a minus 1, your critical, you will have f dash x 0 here. Okay, so on your left only one critical point this time. So your graph will be something like this. I can make idea from here. Your graph will be either like this, or it might be like this also. Here it will change little bit, and then again it will increase like this. It might be like this. Okay, so you can see here. Now see here, in this case, this is what? X square, quadratic polynomial, right? So the chances maximum is this one. You cannot be straight line, obviously it will be parabolic. So you will see that this is minus 1, suppose, right? Let me draw somewhere here. The graph will be something like this, minus 1 here. So somewhere here, suppose the graph will be increasing, and that here it will become neutral, and then again it will decrease like this, something like this. But here it will be 0, that I know, but I don't know whether on the left it will be increasing or decreasing. Graph can be like this also, but I know that at minus 1 it will be neutral, and then the graph will change. It might be like this, or it might go like this also. Okay, but here it will be 0, minus 1. Okay, so let's find out on the left of minus 1 whether it will be decreasing or increasing. So how to find out? Very simple. I will draw number line. This is your minus 1, right? So on your left I want to find, right, on your left whether the graph will be increasing or decreasing. So what I will do, I will take one point, any point you take. Okay, any point you will take means what you will take here, minus 2 you take, minus 2 or minus 3 or minus whatever point you take on your left. Okay, so you can do that one in the rough work. Okay, so what you do is minus 2. Okay, minus 2 I will take, suppose, and we'll put in this derivative, and we'll see what value will come out, positive or negative. If it is negative, if f dash x is negative, we know that this function will be decreasing like this. Okay, if it is positive, then it will be increasing. Okay, so at x equal to minus 1 it is 0, so here you cannot say, it will be neutral at minus 1. We have already seen that, right? Now on your left, whether the graph will be decreasing or increasing, we want to find out, right? So what we will do, we will take one point, say minus 2, and we'll put here. We'll check whether you will get negative or positive value. F dash x, if I take 2 into minus 2 plus 2, what you will get here? Minus 4 plus 2, which is equal to minus 2. So you got negative, right? So you will see that for all value on your left, whatever you will take here and put it here, you will always get negative. So what I can conclude from here, on the rough I have already find out, right? So now f dash x is less than 0 for all x belongs to what? Less than minus 2, right? Less than minus 2 means till what? Till minus infinity. Still from minus infinity to minus 1, whatever value you take x, your f dash x will be negative, less than 0. That's what the meaning here. Okay, now f dash x will be less than 0 for all x belongs to this one. I hope it's clear. X belongs to this one means what? X belongs to this, right? I can take anything from here, I told you, till minus infinity, whatever value you take. Okay, because here you will not get neutral point. Neutral point is only one, this one, minus 1. So either the graph on the left will be increasing or decreasing. So I want to find out. So what I did, I took one point and put it here in the derivative, because through derivative only you can find out, right, whether it is decreasing or increasing. So minus 2 I took it here and put it here. So I have seen that it becomes negative. So you will see that from that only one point, you can know that for all these points on the left, that is still minus infinity, whatever you take, f dash x will be negative. And we know that if f dash x is negative, then your graph will be decreasing. That is, fx will be decreasing. The function will be decreasing. Okay. So how you can write down? Therefore, the function means this one. Okay. The function f is strictly decreasing on minus infinity to minus 1. Okay, so the function is strictly decreasing on this interval. So we already got it. Okay, so next we will find out for right side. Okay, so we already got the idea that this is your -1, right? So on your left of -1, the graph will be decreasing. From left it will come something like this. Okay, something like this it will come. So here it will be negative or neutral, I mean, and after that it will be increasing or decreasing. That I want to find out again. Okay, so what I will do, okay, so let's find out in the number line, in the graph only. This is your -1. So on your right, any point you take, so let's take 1. Okay, and try to put in f dash x, because f dash x only will give you whether it is decreasing or increasing. Okay, so f dash x, if it is positive, it is increasing; if it is negative, it is decreasing. So 1, if you put it in place of x, don't get confused. Okay, this one, don't put it in the function, put it in the derivative. Try to understand that carefully. So it will be 4. So positive value you got, right? So here you got positive, here you got negative, here it is neutral. Okay, so here negative means decreasing, here positive means increasing. So the graph here will be neutral like this, and then again increasing. Okay, it might be here also, but I know that the graph will be like this. So you can see, I will try to show you the graph of this function also. So for first thing, let me write down here, for f dash x, not for f x, now f dash x will be greater than 0, or you can write again, now I have already used, now again f dash x greater than 0 for all x belongs to which interval now? -1 to infinity, right? -1 you cannot include. If you include this, then it will be simply increasing. Okay, so -1 I will take open interval, means I am not including this one because it is neutral here, 0 here. I want to take greater than 0, greater f dash x greater than 0 when it is greater than -1. Okay, you cannot take -1. If you take -1, here it will be equal to 0. So if it becomes equal to 0, then it is simply increasing, not strictly increasing. Okay, to infinity. So under this interval, your f dash x is greater than 0. Therefore the function, okay, the function f is increasing, strictly increasing on what interval? -1 to infinity. That's it. Okay, so this question exactly is not tough. Okay, why students face difficulty in this kind of question is because they don't try to understand with the help of graph. Okay, so try to understand with graph. All question you can easily solve here. So you can see here, I will show you the graph of that function. Okay, what was the function? You can see x square plus 2 minus 5, right? So when I draw this graph, you will see the one which I have shown you. So something like that will come out. Can you see? I already made the assumption. Without drawing graph, I said that the graph will be something like this. So can you see how derivative makes it easy to understand what kind of graph you might get without plotting the graph? Okay, so you can see the graph is decreasing on your left of -1. Can you see when it is -1, it become neutral here. Can you see it become neutral here? Here the tangent, you can consider this line. Can you see it will be parallel to x-axis? So here it will be neutral, and again you can see increasing, and it will increase till infinite. If you keep on moving upside, you will see that x-axis will keep on increasing, and this will also keep on increasing till infinity. That's why from -1 to infinity the graph is increasing, from -1 to minus infinity the graph is decreasing. From left we used to always see. Okay, don't get confused, don't think that the graph is like this, so you might be thinking that it is going up, so increasing. Not like that. We always read graph from left to right. So left to right means it will come like this, decreasing, okay, and then increasing. Okay students, so question number C I have already written for you, okay, so that it won't take much time. So since you have understood, it's exactly same like question number 5. So function is given this one. Okay, so we have find out derivative of that. So simplify this one since it is in the quadratic form, right? So from here, now from here I can easily say whether the f dash x will be positive, negative or not. Okay, from here also you can say, it's not that you cannot say, but the calculation will be a little heavy here because we can simplify this one. That's why we have simplified, so that in a simple way we can find out. Now see here, first thing what we will do, I want to know that I want to know that this graph is increasing or decreasing, and where it is increasing and where it is decreasing. So first thing what we will do, we will find out critical point. So here obviously quadratic, right? You got f dash x, so obviously two zeros you will get. So here -2 and -1, so f dash x is equal to 0, right? For critical point, from there you solve it, x you will get -2 and -1. So -2 -1 I plot it, so I know that the graph here it will be 0, here it will be 0, means the slope will be 0 here. Okay, so the graph might be increasing or decreasing on your left and on your right also, right? So first we will check for left. So if you take any point on the left, that is -3, and put it in this derivative, so instead of putting here you put it here. Okay, -3 if I put here, -3 if I put here, you can see -3 is bigger than this one, so this will give you negative value. This also -3 is, I mean 3 is bigger, right? So negative sign will come here. Okay, 3 is bigger here, so negative sign, so negative, negative, negative. So 3 negative, if you multiply, what you will get? Negative into negative positive, positive into negative, again it will give you negative. So this will give you negative. I don't need the values, I need the sign only, remember that. Okay, so if it is negative, so I know that the graph here will be decreasing, that's confirmed. Okay, so that's why I've written f dash x is less than 0 for all x belongs to -2 to infinity here on your left, right? Minus infinity, so how we will write? Minus infinity to -2. Okay, this is the interval. Next, not only this one, so -2 to -1, what will be the graph? Whether here it will be decreasing or increasing, because at -2 I know, right, it will be 0, neutral. So on your right till here, what it will be? Whether it will be increasing like this or it will be decreasing. So I want to find that. So from this to this you take any point, take 1.5 minus 1.5, between this -1.5 is there, right? So -1.5 if I take here, see how to make idea, you don't have to calculate here. -1.5 plus 2 minus 1.5 plus 1, you don't have to calculate here, you can see here this is negative, right? Now from this what value you will get, positive or negative? This is bigger than my 1.5, right? So plus will come out. Okay, from this 2 minus 1.5 will be how much? Positive number, right? And then here you will get negative. 1.5 is bigger than 1, so negative value you will get here. So negative, this will be positive, this will be negative, this is negative. So negative into negative you will get positive, positive into positive is positive, right? So from this you will get positive values, whatever value you will take between -2 and -1. So this is positive here. So since it is positive, means f dash x is positive, means what? It is increasing here. Okay, so the graph will be increasing here. So what we will write, f dash x is greater than 0, means positive, for all x belongs to -2 to infinity. I am not including this one, because if you include this, we know that here f dash x is 0, not greater than 0. Okay, so if you include here, it will come equal to also, and that in that case it will be only increasing, not strictly increasing. Okay, so this will be strictly increasing on this interval. So that's what we have written. Okay, now on your right you will see that same way you try to take 1 and put it here. 1 1, if you put here positive number, so this is positive and this is negative, so obviously as a whole it will be negative. So this side also negative, means decreasing. So here also decreasing, here also decreasing. So that's why on the interval minus infinity to -2 and -1 to infinity, the graph will be, the function will be strictly decreasing. On minus infinity to -2 and -1 to infinity, it will be decreasing. Okay, so that's the graph. So if I show you the graph, you can see it will be something like this. You can see here I have written already the function. Okay, 2, if you can see here, minus x 2x cube minus 9x square minus 12x plus 1. This is the function, right? So if I draw this graph of this one, you will see that on your left of -2 we have got, right, it will be decreasing, means it will come down like this from the left. Okay, then -2 to -1 it will be increasing, it will go up, and then -1 to infinity, again positive side, this will be decreasing again. We got that, right? Negative here, here negative, on the right positive, negative. So the graph will be like this, then again it will be increasing from here, and again it will be decreasing from here, something like this you will get. So see here carefully, can you see when I draw graph on your left, you see it is decreasing, decreasing from the left, you have to see the graph, right? So decreasing, decreasing, right? Can you see here At -2 it becomes 0, neutral, and then again increasing. Can you see the graph is going upward, increasing till -1 and again start decreasing. So you can see I already made the idea of the graph from the derivative only. Okay, so this is the advantage of derivative. You can easily say what kind of graph you will get, and previously you have seen the application of derivative in the form of rate of change. Okay, so same way here also we have applied some of the importance of derivative we have seen in this case also. Okay, so with this you try to solve your question number D and B. Okay, and E I will show you in the next class. E is little bit different. How to solve it I will show you in the next class. And not only B and D you try other questions also. Okay, whichever you can do it.